All right, we're going to talk about, based on what kind of triangle you have, where the circumcenter and center are. I'm on a website, so if the video doesn't work very well, I can give you the address. It's mathisfun.com/geometry/trianglecenters.html. Video in the computer screen is not the greatest. Okay, so if I take point A, y'all can see right here, I've got this point as my circumcenter, and there's my circle around my triangle. If I take point A, I can move it around. And see how the circumcenter that you're watching, that blue dot right there, see how sometimes it's kind of in the middle of the triangle, sometimes it's not, sometimes it even goes outside the triangle. So what I want you to notice is when I have an acute triangle, my circumcenter is inside. It moves around different places inside, but as long as my triangle is acute, it is always inside the triangle. When I take this and I turn it into a right triangle, so look right there at angle B. See how that looks like a 90-degree angle? When I make that a right triangle, my circumcenter is on the hypotenuse. Okay, so if that's the right angle, this is the hypotenuse, so my circumcenter is on the triangle. And then if I take this and I turn it into an obtuse triangle, see how the circumcenter gets pushed further out? It was here, and now it's pushed further out, and it's outside the triangle. So that's your clue, or that when it's an obtuse triangle, the circumcenter goes outside. So for the circumcenter, if it's an acute triangle, it's inside. If it's a right triangle, it is on the triangle. And if it is an obtuse triangle, it's outside. All right, so now I want you to go back in your ISN to triangle 1. And we filled everything out about the circumcenter. It's made by perpendicular bisectors. It's equidistant from the vertices. The last thing I want you to know about the circumcenter is that it can be inside outside, or on the triangle. Can be inside, outside, or on the triangle. And come down, if you have room, write it down here. If you don't have room, then write it underneath your picture. But I want you to just draw a picture of what each one looks like. So if it's an acute triangle, our circumcenter was inside. If it's a right triangle, our circumcenter was on the triangle, and it was right there on the hypotenuse. Put a C beside that for circumcenter. And if it's an obtuse triangle, our circumcenter was here for the right triangle, then it gets pushed out further, and it's outside the obtuse triangle. Okay? So you need to know, based on what kind of triangle it is, these are the locations for the circumcenter. Inside the acute, on the right triangle, and outside the obtuse triangle. All right, now we're going to look at in-center. So see how the circle's on the inside now? That's our in-center. These are your angle bisectors there. As I grab point A and move it around, do you see that no matter where my in-center goes, or what kind of triangle I have, my in-center stays on the inside of the triangle? Now, this makes sense because the in-center is equidistant from the sides. So if I'm going to be equidistant from these three sides, I have to have a point that's inside the triangle. Going back up to circumcenter, because I want to go back and show you something about that real quick. The circumcenter is equidistant from the vertices. So even though the circumcenter is outside of the triangle right here, if I draw a line from that point to A, to B, and to C, those three lines would all be the same. So it makes sense for a circumcenter to be outside the triangle sometimes because you're trying to find a point that is the same distance from each of the vertices, okay? But when we look at in-center, if we're going to be equidistant from the sides, it has to be inside. So the in-center is always going to be inside, okay? Sometimes you can see the in-center is a little more to the left in the triangle, but it's still the same distance from each side, okay? And before we go and write that down, I want to go back up here to centroid and show you that one. Centroid is made by the medians, okay, and they don't have the tick marks on here, but see how it goes from that point to the vertex? That's your clue that it's the median because it doesn't have the right angles marked. And centroid, if you remember, the property of centroid is that it is the true center. So look what happens as I move this triangle around. See how the centroid always stays in where you think the middle of the triangle would be? Like it doesn't move around very much. It stays in the center. It stays in the middle of the triangle. So centroid is the other one that will always stay on the inside of the triangle because it's the true center. So it has to be on the inside. All right, go to your card for in-center, and on this last little star, we're going to write in-center is always inside a triangle. So it doesn't matter if it's acute, right, or obtuse, the in-center will always be inside. And then go to centroid and do the same thing, right? Always inside a triangle. All right, for our last triangle center, we have orthocenter. And you can see these are altitudes. They go through the vertex. They make right angles, but there are no tick marks. And as I take point A and move it around, you see the orthocenter moves around. As long as my triangle is acute, my orthocenter stays inside. It moves around a lot, but it stays inside. If I make this a right triangle, look at my orthocenter. It's that blue dot right there. As I make this a right triangle, so I'm making angle B the right angle, that orthocenter lands on top of angle B. So as this is a right triangle, your orthocenter is on the right angle. And then if I open it up to make it obtuse, see how the orthocenter shoots out the back? So now my orthocenter is outside. So same thing like the circumcenter. Inside for acute, on the triangle for a right triangle, and then outside for obtuse. Okay, find your card for orthocenter, and on this star, I want you to write can be inside, outside, or on a triangle. So just like the circumcenter, the orthocenter can be inside, outside, or on. And then come down here to this bottom part if you have room. Again, if you don't, then just fill it in underneath the card. But we're going to draw a picture of each one. If it's an acute triangle, your orthocenter is going to be inside of it. If it's a right triangle, your orthocenter is going to be on the right triangle, but the circumcenter was on the hypotenuse. Your orthocenter is going to be back here on the right angle. So orthocenter is on the right angle for a right triangle. And then if it is an obtuse triangle,